Here we go. Who loves you? I do. All right, so we got to find a derivative first, right? That's the first step. Now, a lot of you, we kind of have two first steps. One is f of prime of x is equal to 0. That's just finding the derivative. For some of you, we decided to give you the formula. 2ax plus b equals 0. Okay? Whereas you have a, b, and c, just like the quadratic formula. Okay? But if you do the derivative, think. 2 times 3 is 6. Plus 24 equals 0. If you do the formula, 2 times 3 is 6. What? That's the same thing. Yeah. Okay, so plus 24 is 0. Okay? So, then we solve it. So we subtract 24, I get 6x equals negative 24. I divide by 6, and I get x is equal to negative what? 4. Right? All right. That is your axis of symmetry. Okay? That's our axis of symmetry. That means when I graph this thing at negative 4, go out the door. What? Oh yeah. He's going to break it down for you. What? Okay, so that's all the axis of symmetry says, is that it's symmetrical at this point, at negative 4. At negative 4, we are symmetrical. That's it. Okay? What are we symmetrical about? Well, it's either going to look like this or like this. Is it frowning or is it smiling? Smiling. Because this is positive. Right? We're always smiling in here because math is great. And Dan is greater. We like to call him gooder. He's gooder than most. Okay? He's gooder than toast. Get that? Okay, so. He's the most. He's gooder than toast. And if you don't believe me, you can get ghost. What? I'm here all week. Okay. So, cash.
Wow.
We made it.
You're here.
Alright, so number 2. What did we do for 2? What's the second step?
F of x.
F of x. So f of x is just f of the axis. Okay? F of x equals what? It equals the vertex.
Oh, that sounds gross.
It actually equals y, right? And y is just x and y. X and y is the actual vertex. Right, Ashley?
Yeah, right.
Okay. So, what I do is I plug this in. F of negative 4 equals 3 times negative 4 squared plus 24 times negative 4 minus 16. Whew, that's big. And then we do it. What's negative 4 squared? That's 16. Times 3, that's 30 plus 18, that'd be 48. No. Yeah? Now this better be half or double. Negative times a positive is a negative, and it looks double because 2 24s would be 48, 2 48s would be 96. So 4 times 24 is 96. So that's going to give me minus 48. And if it does that, if this is always the opposite of this, are we on the right track? Yes. Minus 16, minus 16. What is negative 48 minus 16? A big number.
True.
That's a 4. 54 plus 1, 64.
Yep.
That's a big number. All right. So f of negative 4 is 64. Negative. Right? So that means that our vertex is negative 4 and negative 64. How are we supposed to draw that? How do we draw negative 64? You think we can go 1, 2, 3, 4, 5, 6, 7, 8 to 64? No! We don't do that. Alright, what do we do then?
Go by 20.
Go by 20, go by tens. 10, 6, that's good, right? So 10, negative, 20, negative, 30, negative, all the way down to negative 60. And then 64 probably be about, I don't know, quarter of the way to 70, right? Or halfway to 70. A little less than halfway, okay? So then that would be our vertex. And our vertex is smiling, so I know it's going to look like that, right? Okay? So our vertex, oh, that was supposed to be in green. Sorry about that, people. Let me rewrite that in green. Negative 4, negative 64, and then that would be a green. And green and red make purple? No. Come on, give me green. There's green. It's a lovely color. Okay, so next, what's step 3? This is the easiest step, people.
F of 2 times the axis.
Yes. F of 0 equals C. Oh, that's not what you said? Sorry. It's what I heard in my head. Right? So what happens there is we're plugging in a 0 for x. And so x squared, or 0 squared is, well, 0. And 0 times 3 is, well, 0. And 0 times 24 is, yeah, 0. And 0 plus 0 is, yeah, still 0. Right? And so we're going back to what C is. This is C. So f of 0 is equal to negative 16. That's it. What that means is that at 0, I'm at negative 16. So at, oh shoot, then I'm about right here. It's going to come up and go like that. Okay? But what I do to one side, I got to do to the other because this is symmetrical. It's symmetrical. What does that mean? Yeah, that this side looks like this side, right? But we're asymmetrical. See, if you really look at me, like this eye's like this. Bad example. But when you look at a car, the right half of the car should be exactly the same as the left half of the car, right? It's symmetrical, okay? And so we want to go to our next step, which is step 4. We got to find the other piece. This piece that's that far away. Well, that would be 1, 2, 3, 4, right? Because if I'm 4 this way to get to here, then I'd be 4 this way, and I'd be at the same point. Does that make sense? Because it's symmetrical. The same distance it is here is the same distance as it is here. So in essence, 2 of these axes, right? F of 2 times the axis is always going to equal C. So in our case, since the axis is negative 4, 2 times negative 4 is negative 8, well that should equal C. So at negative 8, we should equal negative 16. So we should have a point at 8, negative 16. Negative 8, negative 16. And that should be our other point. But we got to prove it. You got to prove it. So what do you do to prove it? You plug in f of 8. Negative, right? So you go negative